This topic is about reduce systematic error and random error. Error in the measurement system is referring to the difference between the measured value and the actual value. No physical quantity can be measured 100% accurately. It means that there is always an error occurs. The error can be reduced by increasing the consistency and accuracy of the measurements. There are two types of error. The first is the systematic error. Systematic error is the errors that reduce the accuracy of measurement and caused by the faulty instruments and changes in the environment during the measurement. The second type of error is random error. Random error is the errors that occur due to incorrect observation from the observer. These two kinds of errors will be discussed in the coming section. We first talk about the systematic error. Systematic error is the errors reduce the accuracy of measurement and caused by the faulty instruments and the changes in the environment during the measurement. Systematic error is coming from the instrument. Systematic error is displayed repeatedly by fixed magnitude in the same direction. This is either larger or smaller reading than the actual value. There are the examples of systematic error. The first example is zero error. The error that occurs when the measuring instrument doesn't show zero before taking the measurement. Inaccuracy or defects in the measuring instrument, such as the wrong scale. The following are the methods to reduce systematic error. Zero error can be corrected by reading from the measuring instrument, at which the actual reading is the reading of instrument minus with the zero. Inaccuracy or defect in measuring instrument can be avoided by selecting the correct measuring instrument and check its condition before using it. Repeat the measurement using different measuring instruments can help to reduce the systematic error. Now, we talk about the random error. Random errors is the error that reduces the consistency of measurement, and it occurs due to incorrect observation. Different from systematic error, the random errors come from the observer. When the observer read the scale from an inconsistent direction, or careless in measurement. Here, we have two examples of random errors. The first is the parallax error. Parallax error is due to the observer did not read the reading from the correct position. For example, when you need to take the reading from the measurement, which use a rule. Your eye is not at the 90 degree to the object and the scale. The second example is wrong measuring technique. This is due to the misoperation of a measuring instrument during the measurement. For example, when a micrometer screw gauge is used, and its thimble is rotated to close the spindler at the end point, instead of using ratchets. This will squeeze the object too tight, and affect the accuracy of measurement. Here, we have two common methods to reduce random error. For parallax error, it can be avoided if the observer read the reading from the correct position. For example, read the reading at vertical direction above the scale. Repeat the measuring, using the same measuring instrument, over the measured object. And get the average reading. Reading that is too high, or too low, must be eliminated before calculating value. This topic, we will talk about making estimations before taking actual measurement. When there is no suitable instrument is available, the measurement can be accomplished by estimation. Here, we have four measuring estimations to be discussed. We have length estimation, area estimation, mass estimation, and volume estimation. We first talk about the length estimation. Length estimation can be accomplished by comparing the measured object with part of the body, like the arm or foot, or with uniform tools. The example here is a bar which has a 4 foot length, and each of the foot length has 24 centimeters. For the estimation, the length of the bar is 4 foot multiplied with 24 centimeters, it is 96 centimeters. the area estimation. Area of an object is the size of its surface, that covers the object itself. The area is not base quantity, but is derived quantity. It is a combination of two base quantity, two length. The SI unit for area is square of meter. The area of a regular shape can be calculated by using a mathematical formula. For example, the area of a rectangle is equal to its length, multiple with its width. The area of a triangle is 1/2 of the multiplication of its base length with its height. The area of an irregular shape object can be estimated using the graph method. In the graph method, place the object on a graph paper, and its outline is drawn. The calculated number of the square on the graph paper is covered by the object. The of the object can be estimated. The area of one square is 1 cm times 1 cm, it is equal to 1 square centimeter. The leaf on the graph paper has covered 10 squares, the estimated area is 10 times 1 square cm. It is 10 square centimeters. About the mass estimation. The mass of a small object can be estimated from a large sample size. As the small object cannot be measured by using a normal weighing system. Because a normal weighing system is not sensitive enough to measure the object with low mass. For example, 50 sweets are 120 gram, the estimation of one sweet is 120 gram, divided by 50 sweets, which is 2.4 gram. This is about the volume estimation. The volume of a regular shape object can be calculated using a mathematical formula. For example, a cuboid, its volume is equal to its length times its width, and times its height. The volume of a regular or irregular object can be estimated by using the water displacement method. A measuring cylinder is filled with water, and the volume of water is recorded. An object tied with a string and lowered into the water. Record the final volume of the water. The final volume of the water, minus with the initial volume, is the volume of the object. This is the topic 5 of the chapter, density. The density of an object is the mass per unit volume of the object. Another said, it is the mass within 1 unit volume of the object. Density is a derived quantity, and its SI unit is kilogram per cubic meter. Sometimes density is described in gram per cubic centimeter. Formula of density in the calculation is the total mass divided with its total volume. The density of different objects can be compared using the mass. When the objects are in the same volume, it means that, if the objects have the same volume, the object with higher mass will have higher density. This is another topic, the relationship between floating or shinking and density. When objects are put together into a same container, a floating and sinking of the objects will be observed. The object with higher density will sink down in the object with lower density. The object with lower density will float on the top of the object with higher density. When the cork, petrol, wood, water, glass, and mercury were put together into a container, the cork will float on the top, and it has the lowest density, and the mercury will sink to the lowest point of the mixture. The floating sequence will be cork, petrol, wood, water, glass, and mercury, from top to bottom. This topic is determining density of solids, using water displacement. The density of an object can be calculated by dividing its mass with its volume. For a regular or irregular shaped object, the mass can be obtained by using a balance. The volume of the object can be obtained using the water displacement method. This topic we will talk about the phenomena due to differences in density in everyday life. Oil is less dense than seawater. The oil, that leakage from the oil rig, will float on the surface of seawater. Helium gas is less dense. The balloon that filled with helium gas will float in the air. Ice is less dense than water, so the ice float on the of the water. The water in the Dead Sea is very high density, until we can float on the sea. Now, let's discuss the innovations in objects, food or drink, using the concept of density. Various foods and drinks that use the concept of differences in density have been created to attract the consumer. For example, layer drinks with an array of the colored layer.